In section 2 of chapter 13, the concept of correlation coefficient is introduced. I'm going to do exercise 5 on page 436. The City Council of Pine Bluffs is considering increasing the number of police in an effort to reduce crime. Before making a final decision, the council asked the chief of police to survey other cities of similar size to determine the relationship between the number of police and the number of crimes reported. The chief gathered the following sample information, which is shown here. So in these different cities, 1, 2, 3, 4, 5, 6, 7, 8 cities, they observed a number of police force and a number of crimes reported. There are 4 questions in the exercise. A, which variable is a dependent variable and which is independent? B, draw a scatter diagram. C, determine the correlation coefficient. And D, interpret the correlation coefficient. Does it surprise you that correlation is negative? Well, the main objective here is to find the correlation coefficient using Excel. You just type equal correl, open parentheses, from B3 through B10, comma, and then the other variable from C3 through C10. Enter. Negative 0.8744. In other words, the relationship between the two is relatively strong. Now you could have generated quickly here, as I showed you before, a scatter diagram, and if you notice, the higher the police force, the lower the crime. So that's a negative relationship. You could have calculated also the R by using the formula shown in your textbook, the summation of x minus x bar times y minus y bar divided by n minus 1 times sx times sy. That is formula 13.1 on page 433. You can practice this by calculating this manually and confirm that the correlation is minus 0.8744. Now in Excel, by default, whatever you list first is your independent variable or the horizontal, and whatever you list second is your second column is your vertical axis. But you could have had the two reversed and still get the same type of correlation. The correlation value will be exactly the same, will be negative and also 87.44.